Good morning, friends. Today I am giving a lecture on traveling salesperson problem or traveling salesman problem in dynamic programming. First, what is the purpose of dynamic programming? So, dynamic programming is one of the algorithm design technique. It is useful for finding out optimal solution. It is also used for solving optimal problems that have a maximum result or minimum result. Sometimes the problems may require maximum result, sometimes the problems may require minimum result. So the dynamic programming is mainly used for solving optimization problems by using the principle called principle of optimality. The dynamic programming can be processed in stages. In each and every stage, we can take a sequence of decisions. By using that optimal decision, we can guaranteely get the optimal solution to the given problem. So principle of optimality is the one of the main principle that is used in dynamic programming to get the optimal solution. So suppose if the problem is very big problem to solve, this problem can be divided into some sub-problems. Each and every sub-problem can be solved in optimal way. Then the sum of the solutions of the sub-problems in optimal may produce the optimal solution to the original problem. So in this way, we have to find out the optimal solution by using the principle of optimality and we taken a sequence of decisions. Finally, we get the optimal solution to the given problem. So now our problem is traveling salesperson problem. So it is one of the application of dynamic programming. So what is traveling salesperson problem? So this traveling salesperson problem can be explained with one example, that is postal van example. Postal van example. Suppose there are n post offices in a particular city. Suppose we can take one Hyderabad city. In that Hyderabad city, several number of post offices are located in different areas. So here we can take one postal van. This postal van can start from one post office at one location. It can collect all the mails from all the post offices that are located at different places. So after collecting the mails from different post offices at different locations, finally it can reach where the postal van started. So starting point is one post office and ending point is same post office. The remaining time, the postal van collects all the mails at different post offices that are located at different places. Finally, we reach where the postal van starts at which post office. So this is one tour. So the main objective of traveling salesperson problem is we have to minimize the cost of the tour. So here the edge, suppose we can take an edge. That edge is one post office at one location to another post office in another location. These two post offices are connected by using a edge. What is the edge cost? The distance between this post office to this post office is the cost of the edge. Suppose, so this is one city. In this city, this is one post office, 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 and all the dots are one post office. So this is a Hyderabad city. So these dots represents the post offices that are located at different places. So the postal van starts at this post office, and this postal van collects mails from all the post offices that are located in the entire city, and finally it reaches the at which post offices it was started. So this is the example for traveling salesperson problem. So here the postal van starts at this place, collects mails from all the post offices that are located at different places in the entire city, and finally it reaches the post office where it was started. So this is one. This situation can be represented as a graph. So the nodes of the graph represents a post office. The edge represents, suppose this is one edge. So this is the edge contains two vertices. This vertex represents one post office at one location. This vertex represents another post office at another location. So the edge cost is distance between two post offices at different places. Okay, so this situation can be represented as a graph. So for constructing this graph, we can require n+1 nodes. N is nothing but number of post offices. Here 1 is nothing but starting post office and ending post office. The edge cost represents the distance between two post offices. So this is the example for postal van. This is the example postal van for traveling salesperson problem. Now, how to describe the traveling salesperson problem? Suppose let G is equal to V comma E is a directed graph. In that one, V represents the set of vertices and E represents the set of edges. And edges are going through some edge cost in the graph G. Its cost is represented by Cij. Cij value is always greater than 0. First, in the traveling salesperson problem, for the given graph, we have to construct the adjacency matrix. To construct the adjacency matrix from the given graph, we have to follow some rules. Suppose there is a direct edge between two vertices. What is the weight? That weight represents the cost of the edge. Suppose any self loop is there. In that self loop, the starting vertex of the edge and ending vertex of the edge both are same. The cost is 0. If there is no direct edge between any pair of vertices, so its cost can be represented by infinity. So by using these three rules, first we have to construct the adjacency matrix. So these are the three rules. So if I equal to j, any self loop is there, starting vertex of the edge and ending vertex of the edge both are same, it can be represented as I equal to j. So its cost value is equal to 0. Next, if I comma j is an edge, direct edge, So it belongs to the edge of a given graph. Its cost can be represented by its weight. Its weight can be represented by Cij. Suppose there is no direct edge between any pair of vertices, so that edge does not belong to edge of graph G. So then the cost can be represented by infinity. So by using these three rules, we have to construct the adjacency matrix. Our main objective is we are starting from one single vertex, visiting all the vertices in the given graph exactly once, and finally reach to the destination vertex, that is starting vertex. So here this is one tour. This is a directed cycle. It includes all the vertices that are visited exactly once except the starting vertex and ending vertex. So this is a complete tour. Our main objective is the cost of the tour to be minimum. The cost of the tour is minimum. So this is our main goal. What is the tour we have planned? That tour cost to be minimum. Here the optimal solution is we have to find out the tour of minimum cost. So here let G of I comma S. So I is starting vertex. S means what are the vertices to be visited exactly once and finally reach to the starting vertex. So G of I comma S be the length of the minimum shortest path starting at vertex I, going through all the vertices in exactly once and terminating at vertex I. So this is a starting and ending vertex, both are same. So here the tour starts at vertex I, visiting all the vertices in the given graph exactly once. So, and finally it reaches to the destination vertex I. So here S is nothing but what are the remaining vertices to be visited in the given graph exactly once. Here starting vertex is I, ending vertex is I. S represents the what are the remaining vertices in the given tour to be visited exactly once. So this is the formula for finding out the optimal solution in traveling salesperson problem. G of I comma S is equal to minimum of Cij plus G of J comma set of S minus set of J, where J belongs to S, where S is equal to V minus set of 1. V is nothing but what are the set of vertices to be visited in the given graph exactly once minus starting vertex or ending vertex. Oh, here 1 is nothing but it is a starting vertex and it is also ending vertex. So it can be visited 2 times. Because of that reason, we can eliminate 1 time. So then all the vertices to be visited exactly once. Our main objective is to find out the tour of optimal or minimum cost. Our main objective is we have to find out the tour with minimum cost.